Okay, okay. So guys, someone just called me. They need my help as an engineer because I am tasked to designing a pedestrian bridge that will be built over a curved landscape. So to estimate the materials needed and ensure a stable foundation, I must calculate the exact land area beneath the bridge enclosed by the given curves. So now let's compute this. Let's start computing this in order for them to have a stable, safe, and efficient bridge that will be used by them in their everyday lives. So guys, I'm sorry for the background noise because I'm currently here in my construction project that will be finished by tomorrow. So let's start. Goodbye. So good morning. This final project will be entitled Engineering the Perfect Pedestrian Bridge, Calculating Land Area for Structural Design. So now, let's start our computation with ARCHIMEDES in order to determine the area. By using the functions of y is equals to 4 minus x squared, which determines the parabolic function and the arch of the bridge, and followed by y is equals to x plus 1, which determines a linear function, and the ground, which is located beneath the bridge, and over the interval of a is equals to -2 to b is equals to 1. So our goal here is to compute the area to determine the area of the enclosed region using definite integrals. So basically, definite integrals will help us in order to find the empty space that will help us build the strong foundation of the pedestrian bridge for the people who's gonna use it every day. In order to solve this problem, we will use a formula of area is equals to integral from a to b of f of x minus g of x dx. So basically, a and b here is the x and y axis. So a is the x-axis and b is the y-axis in order to have a simple understanding about this. And let's remember that g of x is always less than or equal to f of x. So 4 minus x squared basically has a higher degree than x plus 1. We will put the 4 minus x squared in f of x, and x plus 1 will be substituted by the g of x. So basically, we have a is equals to integral from -2 to 1 of 4 minus x squared minus x plus 1 dx. So as we can see here, negative x plus 1, it will be negative x plus 1 will be negative value since it has a negative sign outside the parenthesis. So 4 minus 1 is going to be 3, and negative x squared bring down since it doesn't have a like term, and negative x bring down since it doesn't have a like term. So we have a is equals to integral from -2 to 1 of 3 minus x squared minus x dx. So we will find the antiderivative of this. So we have 3x minus x cubed over 3 minus x squared over 2 from -2 to 1. So now we will multiply it. 3 times -2 is equivalent to -6. -2 raised to 3 over 3 is equivalent to 8 over 3. -2 raised to 2 over 2 is equivalent to 2. So we have -6 minus 8 over 3 minus 2 from the lower boundary. So from the upper boundary, 3 times 1 is equivalent to 3. 1 raised to 3 over 3 is 1 over 3. 1 raised to 2 over 2 is 1 half. So from the upper boundary, we have 3 minus 1/3 minus 1 half. So now we will subtract it. So we can get area is equals to 13 over 6 minus -16 over 3. So as we can see here, we can multiply the negative sign into -16 over 3. So we can get an area is equals to 13 over 6 plus 16 over 3. So it has a GCF of 6. So now 6 divided by 6 is equals to 1 times 13 is 13. And 6 divided by 3 is 2 times 16 is 32. So now we have an area is equals to 13 over 6 plus 32 over 6. So area is equals to 45 over 6. So we have an area of 7.5. So now in order to visualize more of this project of us, we have here the final look of our project, which it looks so safe, efficient for the people to use it. And as we can see here in the graph, the shaded part of it is the empty space or the area that we've been looking for and has a value of 7.5 square units. So now we can determine on how we can build this pedestrian bridge safely. So finally, this computed value of 7.5 square units will help us to determine on how much materials is required in building this. And lastly, it will ensure us that this bridge will have a stable and well-supported foundation in order for the people to use it on their everyday walk, jogging, or on their way to work, school, or on their errands with their self. So, goodbye, as this is the last project with ARCHIMEDES together with you guys. So, see you around, guys. Bye-bye!